The year is 1910. A biting wind howls through the snow-laden pines of the Minnesota Northwoods. The temperature has plummeted to 40 degrees below zero, and a lone lumberjack is miles from the relative warmth of the bunkhouse. His hands are numb, his face is a mask of ice, and a towering white pine, a tree that has stood for a century, has just fallen the wrong way, trapping his leg. He is alone, injured, and facing a slow, freezing death. How could he possibly survive? What tools, built with his own hands from the raw materials of the forest, could save his life? And what was the one ingenious device that could turn a fallen tree into a life-saving shelter in a matter of hours? These 7 tools weren't just for logging, they were the keys to survival in the brutal, unforgiving world of the northern forests. My name is Sam, and this is Wild America. Number 1. The Peeve and Cant hook. A massive white pine log, 4 feet in diameter and weighing several tons, is wedged between 2 boulders in a frozen river. A team of lumberjacks, their breath crystallizing in the frigid air, must move it or risk losing the entire log drive. They can't use dynamite for fear of shattering the log. Instead, they turn to a simple but powerful tool, the Peeve. With a combination of leverage, brute force, and a deep understanding of physics, they sink the Peeve's sharp point into the log and, working in unison, slowly, painstakingly, roll the massive timber out of its trap. The Peeve and the Cant hook were the lumberjack's primary tools for moving and manipulating logs. While they may seem like simple levers, they were sophisticated devices designed to multiply a man's strength and allow him to control the immense weight of a freshly felled tree. The Peeve, invented by Joseph Peeve in Maine in the 1850s, was a 5 to 6 foot long wooden lever with a sharp, pointed metal spike at the end and a hinged, C-shaped hook. The Cant hook was similar but without the pointed spike. The handle of a Peeve was typically made from rock maple or yellow birch, woods known for their strength and flexibility. These hardwoods could withstand the tremendous stress of moving logs weighing 2,000 to 8,000 pounds. The handle was turned on a lathe to a diameter of 2 to 2.5 inches, providing a comfortable and secure grip even when wearing thick leather gloves in sub-zero temperatures. The length varied from 48 to 72 inches, with longer handles providing greater leverage for larger logs. The metal components were forged from high-carbon steel containing 0.7 to 1.0% carbon, heated to 2,100 degrees Fahrenheit in a coal forge and hammered into shape on an anvil. The spike of the Peeve was 4 to 6 inches long and tapered to a sharp point at a 15-degree angle, allowing it to be driven deep into a log with a single powerful thrust. The hook was 6 to 8 inches long and curved to a sharp beak-like point at a 45-degree angle, which would bite into the wood and provide a secure grip capable of holding several tons of force. The socket that held the handle was forged as a single piece with the hook and spike, creating a joint that could withstand tremendous stress without breaking. The handle was secured in the socket with a steel wedge driven through both the socket and the handle, creating a mechanical lock that would not fail even under extreme loads. A skilled blacksmith could forge a complete Peeve head in 4 to 6 hours, but the tempering process required another full day to ensure the steel would hold its edge and not become brittle in cold weather. The lumberjack would use the Peeve to roll, lift, and pivot logs. By sinking the spike into the log and using the handle as a lever, a single man could move a log weighing several thousand pounds. The key was to use the tool to apply force at the right point, to find the log's center of gravity and use it to his advantage. A skilled lumberjack could dance with a log, rolling it with a grace and precision that belied the immense weight of the timber. Number 2. The Crosscut Saw. Two lumberjacks, their faces grim with determination, stand on either side of a massive white pine. The tree is 6 feet in diameter, and its trunk is as straight and true as a cathedral pillar. They are using a 2-man crosscut saw, a 10-foot-long ribbon of steel with razor-sharp teeth. The saw sings as it bites into the wood, the rhythmic pull and push of the men a testament to their strength and skill. It will take them hours to fell the tree, a slow and arduous process, but the saw, a simple tool of steel and wood, will eventually bring the giant crashing to the forest floor. The crosscut saw was the lumberjack's primary tool for felling trees and bucking them into logs. These saws were marvels of engineering, designed to cut through massive trees with surprising efficiency. A typical two-man crosscut saw was 8 to 12 feet long and made from high-quality crucible steel. The blade was 6 to 8 inches wide and tapered from the cutting edge to the back, which helped to prevent it from binding in the cut. The teeth of the saw were its most important feature. There were two types of teeth, cutter teeth and raker teeth. The cutter teeth, which were sharpened to a razor's edge at a 60-degree angle, would score the wood fibers, while the raker teeth, which were shorter and chisel-shaped at a 90-degree angle, would remove the wood chips from the cut. The pattern of the teeth was critical to the saw's performance. A typical pattern was 2 cutter teeth followed by a raker tooth, repeated across the entire length of the blade. The teeth were set, or bent, to the left and right at precise angles of 15 to 20 degrees, which created a kerf, or cut, that was 1/8 to 3/16 inch wider than the blade thickness, preventing it from binding in the cut. The depth of each tooth was exactly 1/4 inch, and the spacing between teeth was 1 inch on center. A 10-foot crosscut saw would have approximately 120 teeth, each hand-filed to exact specifications. The steel used in crosscut saws was crucible steel, made by melting iron and carbon in clay crucibles at temperatures exceeding 2,800 degrees Fahrenheit. This process created a uniform, high-quality steel with a carbon content of 0.8 to 1.2%. The blade was forged to a thickness of 1/8 inch at the cutting edge and tapered to 3/32 inch at the back, reducing weight while maintaining strength. The entire blade was then heat-treated by heating to 1,475 degrees Fahrenheit and quenching in oil, followed by tempering at 400 degrees Fahrenheit to achieve the perfect balance of hardness and flexibility. Sharpening a crosscut saw was a fine art. A skilled saw filer would use a set of specialized files and gauges to sharpen each tooth to the correct angle and height. A poorly sharpened saw would be difficult to pull and would cut slowly, while a well-sharpened saw would glide through the wood with a satisfying hiss. The handles of the saw were made from hardwood, usually beech or maple, and were designed to be comfortable to hold for long periods. The handles were attached to the blade with a set of bolts and could be adjusted to suit the height and preference of the sawyers. Number 3. The felling axe. A lumberjack stands at the base of a towering spruce. He is using a felling axe, a tool that is an extension of his own body. With a series of powerful, precise blows, he cuts a deep notch into the base of the tree. The notch is perfectly angled, designed to control the direction of the tree's fall. He then moves to the other side of the tree and begins to make the back cut. With a final mighty swing, the tree begins to groan, and then, with a deafening crash, it falls exactly where the lumberjack intended. The felling axe was the lumberjack's most personal tool. Each man had his own axe, and he would spend hours sharpening and honing it to a razor's edge. A good felling axe was a work of art, a perfect balance of weight, shape, and materials. The head of the axe was made from high-carbon steel containing 0.7 to 0.9% carbon and weighed between 3 and 5 pounds, with the most popular weight being 3.5 pounds for optimal balance between power and control. The shape of the head was critical to its performance. A good felling axe had a thin, tapered bit with a cutting edge 4.5 to 5 inches wide, ground to a 25-degree angle on each side, which allowed it to bite deep into the wood with minimal resistance. The cheeks of the axe were ground thin, typically 3/8 inch thick at the widest point, to reduce friction as the axe penetrated the wood. The pole, or back of the head, was hardened to 45 to 50 HRC, Rockwell Hardness Scale, so that it could be used to drive steel wedges without mushrooming or chipping. The eye of the axe, where the handle was inserted, was forged with a slight taper and measured 2 inches wide by 1.25 inches tall, creating a secure fit that would not loosen under heavy use. The transition from the eye to the bit was carefully forged to eliminate stress concentrations that could cause the head to crack. The steel was heat-treated using a differential hardening process. The bit was heated to 1,475 degrees Fahrenheit and quenched in water, creating a hard cutting edge with a hardness of 58 to 62 HRC. The eye and pole were heated to only 1,200 degrees Fahrenheit and air-cooled, leaving them softer and more shock-resistant. This differential hardening created an axe that would hold a sharp edge while being tough enough to withstand the shock of chopping. The handle of the axe was made from hickory, a wood known for its strength and ability to absorb shock. The handle was 32 to 36 inches long and was curved in a graceful S shape, which provided a comfortable and ergonomic grip. The handle was attached to the head with a wooden wedge, which was driven into a slot in the top of the handle, expanding the wood and creating a tight, secure fit. Sharpening a felling axe was a ritual. The lumberjack would use a file to shape the edge of the bit and then a whetstone to hone it to a razor's edge. A sharp axe was a safe axe. A dull axe would glance off the wood, while a sharp axe would bite deep and true. Number 4. The draw knife. A lumberjack is building a new bunkhouse. He needs to create a series of perfectly fitted joints for the log walls. He uses a draw knife, a simple tool with a long, sharp blade and a handle at each end. With a series of smooth, controlled strokes, he shaves thin layers of wood from the logs, creating a tight, weatherproof seal. The draw knife allows him to shape the wood with a precision that would be impossible with an axe or a saw. The draw knife was a versatile tool that was used for a variety of woodworking tasks, from peeling bark off logs to shaping handles for tools. It consisted of a long, sharp blade, typically 10 to 15 inches long, with a handle at each end. The blade was made from high-carbon steel containing 0.8 to 1.0% carbon and was forged to a thickness of 1/8 inch at the cutting edge, tapering to 3/16 of an inch at the back. The blade was ground to a 20-degree bevel on one side only, creating a chisel-like edge that would slice through wood fibers cleanly. The handles were made from hardwood, typically ash or hickory, and were angled at 15 degrees to provide a comfortable and secure grip that allowed the user to apply maximum force while maintaining control. Each handle was 5 to 6 inches long and turned to a diameter of 1.25 inches with a slight taper toward the ends for a secure grip. The handles were attached to the blade with a tang that extended 2 inches into the handle and was secured with a steel pin driven through both the tang and the handle. The blade was heat-treated by heating to 1,475 degrees Fahrenheit and quenching in oil, then tempering at 375 degrees Fahrenheit to achieve a hardness of 60 to 62 HRC. This created a blade that would hold a sharp edge while remaining tough enough to withstand the lateral stresses of draw knife work. A properly sharpened draw knife could remove shavings as thin as 0.001 inch, allowing for extremely precise work. The lumberjack would use the draw knife by pulling it towards him, shaving off thin layers of wood with each stroke. The depth of the cut could be controlled by changing the angle of the blade. A skilled user could create a smooth, finished surface with a draw knife, or he could remove large amounts of wood quickly. The draw knife was an essential tool for log building. It was used to create the notches that held the logs together, to flatten the surfaces of the logs so that they would fit tightly together, and to shape the ends of the logs so that they would shed water. Number 5. The auger. A lumberjack is building a raft to transport logs down a river. He needs to join the logs together with a series of wooden pegs. He uses an auger, a large, hand-cranked drill, to bore a series of holes through the logs. The auger is a simple but effective tool, and it allows him to create a strong, durable raft that will withstand the rigors of the river. The auger was a hand-cranked drill that was used to bore large holes in wood. It consisted of a long, spiral-shaped bit, a handle for turning the bit, and a breastplate for applying pressure. The bit was made from high-carbon steel containing 0.9 to 1.1% carbon and was available in sizes from 1/2 inch to 2 inches in diameter. The spiral flutes were forged at a 30-degree angle to the axis of the bit, creating an efficient chip-clearing action that prevented the bit from binding in deep holes. The cutting edge of the bit was ground to a 60-degree point with 2 sharp spurs that scored the wood fibers before the main cutting edge removed the material. This design prevented tear-out and created clean, precise holes. The shank of the bit was 18 to 24 inches long and was forged with a square cross-section that fit into a corresponding socket in the handle assembly. The handle consisted of a wooden crossbar 14 to 16 inches long, made from hickory or ash, with a steel socket in the center that held the bit. The breastplate was a curved steel plate, 6 inches wide by 4 inches tall, that was attached to the handle assembly with a swivel joint. This allowed the user to apply steady pressure while turning the handle, even when drilling at awkward angles. The steel components were heat-treated by heating to 1,500 degrees Fahrenheit and quenching in water, then tempering at 400 degrees Fahrenheit to achieve a hardness of 58 to 60 HRC. A skilled operator could drill a 1-inch diameter hole through 12 inches of hardwood in approximately 15 minutes, maintaining a drilling rate of 0.8 inches per minute. The lumberjack would use the auger by placing the point of the bit on the wood and turning the handle. He would apply pressure to the breastplate with his chest, forcing the bit into the wood. It was a slow and laborious process, but it was the only way to bore large, deep holes in wood before the advent of power tools. The auger was an essential tool for a variety of construction projects, from building rafts and bridges to constructing bunkhouses and furniture. Number 6. The whetstone. A lumberjack sits by the fire in the evening, carefully sharpening his axe. He is using a whetstone, a flat rectangular block of abrasive stone. With a series of smooth, circular motions, he hones the edge of the axe to a razor's sharpness. The whetstone is a simple tool, but it is the key to the lumberjack's productivity and safety. A sharp axe is a safe axe, and a safe axe is a productive axe. The whetstone was an essential tool for keeping the lumberjack's cutting tools in top condition. It was a flat, rectangular block of natural abrasive stone, such as novaculite or silicon carbide. The whetstone was used to sharpen axes, knives, and other cutting tools. The lumberjack would use a coarse whetstone to remove nicks and dings from the blade, and then a fine whetstone to hone the edge to a razor's sharpness. Sharpening a tool on a whetstone was a skill that was learned through years of practice. The lumberjack would hold the blade at a precise angle to the stone and use a series of smooth, circular motions to sharpen the edge. He would use oil or water to lubricate the stone and to float away the metal particles that were removed from the blade. A sharp tool was a safe tool. A dull tool was more likely to slip and cause an injury. A sharp tool also made the lumberjack's work easier and more efficient. A lumberjack with a sharp axe could fell a tree in half the time it would take a man with a dull axe. Number 7. Snare wire. A lumberjack is deep in the forest, miles from the nearest settlement. His food supplies are running low, and he needs to find a source of fresh meat. He uses a length of snare wire, a thin, flexible wire made from brass or steel, to build a series of traps. He sets the traps along a game trail, and the next morning he finds a rabbit in one of his snares. The snare wire has provided him with a life-saving meal. Snare wire was a simple but effective tool for trapping small game. It was a thin, flexible wire, typically 20 to 24 gauge, made from brass or steel. The lumberjack would use the snare wire to build a simple loop trap. He would set the trap along a game trail, a path that was frequently used by animals. When an animal walked through the loop, the snare would tighten around its neck, trapping it. Building a snare was a simple process. The lumberjack would form a loop in the end of the wire and then attach the other end to a tree or a stake. He would then prop the loop open with a small twig so that it would hang at the correct height to catch the animal. The key to a successful snare was to place it in the right location. A skilled trapper would look for signs of animal activity, such as tracks, droppings, and browsed vegetation. Snare wire was a lightweight and compact tool that was easy to carry. A lumberjack could carry 100 feet of snare wire in his pocket, enough to build dozens of traps. It was a reliable and effective way to obtain fresh meat in a survival situation. These 7 tools, built with ingenuity and skill from the raw materials of the forest, were the lumberjack's keys to survival. They were more than just tools. They were an extension of the lumberjack's own body, a testament to his strength, his skill, and his unbreakable will to survive. If you want to learn more about the incredible ingenuity of the men who built America, be sure to watch our video, How Lumberjacks Built Bunkhouses to Survive Frozen Forest Camps. And for a look at how another group of American pioneers survived in a different but equally harsh environment, check out How Cowboys Survived Deadly Heat on the Cattle Drives. Stay safe, and we'll see you next time on Wild America.